In previous video, we have shown that multi-layer partial polarizer can produce phase shift, which means that the microwave has changed its effective speed. This effect is usually related to a phenomenon called refraction, which is usually identified by change in wave direction. Without directional change, speed change of a wave is rarely called refraction. In this video we are trying to emulate refraction by arranging many layers of partial polarizers in prism shape. We have successfully done this using metamaterial prism built by arrangement of many metal cylinders. Now we try to replicate the experiment using thin wires as the building block of the prism. The prism is built using 2 electronic circuit boards as the bases, and 4 pillars made of paper. The wires are then assembled through the holes in the circuit boards and bonded by tin solder. The distance between adjacent holes are 10 mm. With transmitter and receiver arranged to get maximum scale intensity, the prism is placed in front of the transmitter. When the prism is oriented to the narrow side facing the transmitter, the receiver shows near zero intensity. Now we turn the prism so the wider side is facing the transmitter. The receiver shows intensity around 40%. Let's scan the intensity at other angle. It seems that the maximum intensity is still in the original position, which means that we don't find directional change here. Now both the transmitter and receiver are rotated to 45-degree polarization angle. When the prism is placed in front of the transmitter facing on narrow side, the receiver shows half intensity reading. When the receiver is rotated to 0 degree, the reading drops to 0. When the receiver is rotated to 90 degree, the reading shows around 90% of maximum scale. Now we'll return the receiver to the same orientation as the transmitter, and then scan the microwave from other position. We get an unexpected result when the receiver shows some intensity reading, at some point where the microwave seems to bend to the opposite direction compared to normal prism. Weirder still, that the polarization angle of the microwave there is perpendicular to the transmitter, with intensity around 30% of maximum scale. Now we have moved the receiver to the right side. When it is rotated to vertical polarization, the intensity goes up to 10% of maximum scale. The arrangement here resembles a setup for internal reflection. Let's return the transmitter and receiver with 45-degree polarization angle. The prism is then placed in front of the transmitter facing on wider side. The intensity drops to 50%. When the receiver is rotated, the intensity increases to nearly 70% at horizontal position. And when it is rotated to the vertical position, we get the minimum intensity of 20%. It shows that the received microwave has become elliptically polarized.